So this is lesson 2, and it's talking about net ionic equations. And as you see, even from the meme here, it's a bit weird, but we will go through this as well together. Okay, so when we are talking about net ionic reaction, it's a chemical reaction that includes only reacting entities. So only whatever is reacting, whatever is it's there as a spectator standing there, it's not considered to be as a part of net ionic reaction. So let's see an example. Zinc reacts with copper sulfate. On the very first step, what we will do is we will write a balanced equation, chemical equation, reaction. Okay, so in this case, so what we have is zinc in a solid state is reacting with copper sulfate, so CuSO4 is in aqueous solution, and it's producing copper solid and zinc sulfate in aqueous solution, and this is defined based on the fact that zinc and sulfate are soluble. And then as the second step, what we will do is we will write a total dissociation equation or total ionic equation. So we will see, is it dissociated, is it or not, based on the fact, is it soluble or not. So total ionic equation. This is known also as ions. So writing ions. And then as a third step, we will cancel out whatever is a spectator, meaning that is the same on both sides. So for step 2 on this example that we have here, we will have zinc solid, and then we will have copper 2 plus in aqueous solution plus SO4 2 minus in aqueous solution. And then here we will have copper solid plus zinc 2 plus in aqueous solution plus SO4 2 minus in aqueous solution. Okay, so now as you see here, we have those entities. We have zinc as a solid, we have copper 2 in aqueous solution, we have sulfate in aqueous solution, we have copper in solid state, and then we have zinc 2 in aqueous solution and sulfate in aqueous solution. So now, as you notice here, sulfate and sulfate are the same in both sides. And same thing as we do in math when we have two numbers or variables on the same side, then we cancel out as the same thing. Then nothing else is the same, because here is a zinc and here is a zinc ion. Here is copper ion and here is copper solid. So now based on this, after we cancel out, we write that is known as the net ionic equation or reaction. which is what is left now. In this example, SO4 2- is considered to be a spectator ion because it is on both sides of the reaction. Okay. So net ionic reaction for this example will be zinc solid plus copper ion in aqueous solution, and then copper solid plus zinc aqueous solution 2+. Okay, so let's move on now to writing total ionic and the net ionic for the reaction of silver nitrate with potassium chloride. Okay, so let's write a balanced chemical reaction. First one, a balanced chemical reaction. So this, in this case, will be NO2 in aqueous solution. Why is this in aqueous solution? Because what we will NO3, because it is silver nitrate. Okay. Why is it in aqueous solution? Because nitrate is soluble with silver. Plus potassium chloride, again in aqueous solution, because based on the solubility table, they are soluble. And then we'll have, since we are dealing with the double replacement reaction, then we define what is the state of each of them. State of matter. And now silver and chlorine are not soluble, so therefore what we will have is we will have it into solid solution. Now total ionic reaction will be everything that is in aqueous solution will be dissociated pretty much. So now what we will have, change the color so that you can see. Silver in aqueous solution plus NO3 in aqueous solution plus potassium in aqueous solution plus chlorine in aqueous solution ion. And then here we will have potassium plus NO3. And since this is solid, we will leave it as not dissociated because the solid will form a precipitate, is not soluble. Okay. So now, what do we have common in both sides is this one here, NO3 and NO3. And we'll have potassium and potassium. So then whatever is the same, it's cancelled out. This being total ionic reaction, net ionic reaction. Will be whatever is left. So Ag aqueous solution plus Cl aqueous solution, AgCl solid. Okay. Let's take a look at the other example. So what we have here is potassium phosphate and calcium chlorate. Let's write a balanced equation. So this is a balanced equation for potassium phosphate and a calcium chlorate. You should try and do it on your own because you will have questions like this that you have to write the equation and then balance it. Now, together we will define the state of matter. So for phosphorus, we have whatever is in group 1 plus NH4 plus are soluble. Potassium is in group 1, so therefore this will be aqueous. And then we have ClO3 chlorate, which is on the second column of your page 6 data booklet of solubility table. So it is most beside RbClO4 and so on. So therefore, since this is not on the third row of your table, this is aqueous as well. And then we have ClO3, same deal. It's most is soluble beside whatever. So this is aqueous solution. And then we have PO4 is with whatever is in group 1 plus NH4 plus, and for most of them is not soluble. So this is soluble. Now let's write dissociation equation, so meaning total ionic equation, this being balanced reaction. Now let's write a total ionic reaction in which we will write all the entities there. Okay. So we'll have six potassium, why 6? Because 2 times 3 is 6. 6 potassium, 2 phosphorus with a charge of -3. And as you see here, all the charges, net charge should be 0. Okay, so 6 plus 6 minus 6, 0. Plus 6 minus 6, 0. Plus 6 minus 6, 0. So net charge has to be 0. Now, what do we have common here in both sides is 6 potassium and 6 potassium here. And then what else we do have common is 6 chlorate and 6 chlorate. Those 2 ions are called spectator ions. So if you are asked to identify which one is spectator ions, are K plus and ClO3 minus. And they should be the same. So same number that you have here, same number should be on the other side. This is why we have a balanced reaction. And then as a net ionic reaction, what we will have will be 2PO4 3 minus in aqueous solution plus 3Ca2 plus in aqueous solution. That will be Ca3PO4 2 in solid state. Okay, and now this will be your work. For the following reaction, write a balanced equation, total ionic and the net ionic. So those will be your practices for net ionic reaction. We will have more examples in class, so don't worry too much about it.